Good morning, everyone. Uh, Today, first of all, I will discuss few things. I have seen the students, most of the students are doing some mistake in quiz, and I just want to make you cautious to do the same mistake over and over in your first test. So one thing is for rounding the values. Most of the students are doing mistake for rounding the values. I don't know most of you are familiar with it or not, but when I ask you to round your answers up to 2 decimal places, or up to 3 decimal places, or up to 4 decimal places, it will always be written. So you have to make sure that how many decimal places I ask you to round the values of the given answer. So for instance, if you are rounding the value for 2 decimal places, let's say I got the mean or standard deviation or whatever the Z score you are finding out. And the value is something like this, like rounding value up to 2 decimal places. So what does it mean? For instance, you are going to get the value on your calculator, like let's say 1.34568, right? So you have to, it might be longer because sometimes calculations has long values with long digits. So what you have to do, so 2 decimal places, it means after point, after this period, I am going to get these values. But after these two values, you have to look for this third digit. If this third digit is 5 or more than that, like 5, 6, 7, 8, 9. If these values are there, then you always have to round the second digit more than one value. So for instance, here 1.34, so rounding value will be 1.35, right? So, or or if you have, like, for instance, 1.34, let's say 368, then you don't need to make it more digit, add more digit onto it. So for up to 2 decimal places, it will be 1.34 as it is. Your answer will remain the same. So this is how you will have to do. So can you tell me, I have the same question with all of my other students who are online right now. So can you tell me what will be the rounding value for this number up to up to 4 decimal places? What will be the answer you will write down? 1.3457. So the same question is from my online students. Are you there? I can see Maggie and Tia. Are you there?
Yes.
Are you unable to mute? Okay, right. Right. Okay. So are you getting my point? So how you have to calculate the value up to four decimal places. So if I am asking you for 4 decimal places, so it means you are rounding the value 1.3457, because after 6 the value is more than 5 or more than 5. If it is 5, you still have to round the value. But if something like 0 to 4, if you have value, then you don't need to round the value. Okay. So this is the thing for rounding values. I hope you are getting it and you will not do the same mistake over and over. The next thing is for the percentile. So if I'm asking you to find the percentile for some person with a given height or with a given age or with a given score, winning points, whatever is it. So if you have to find the percentile of the given person, like I remember I told you last time in the lecture even, that if we are going to get the height of people, so there might be some people who have smaller heights like this, like random people I'm making. So if I have to find the height of these people, like this person, like their total number of people are 5 in there. So if I want to calculate the percentile height of this person, then I have to include this person in all the people who have less values, because we are going to take inclusive definition, not exclusive. I can understand that most of the books write down for exclusive definition. They say, okay, if the percentile you are going to get for this person, then you have to look all the people who have their height or marks lower than that. But what it does, it will exclude this person, for which person you are going to get the height or percentile score. So if you are taking this out person, so it is not going to include that person for which you are going to find out where he is existing at the point. So what position he is having, so what position a person is having. So in order to do that, you have to calculate that person position as well. So in this case, the total number of people are 5. So I will be writing for percentile score for this person. Let's say this is x1 x2, this is x1, this is x3, and this is x4, and this is x5. So I'm going to include x 2 and all the values that are less than that, x3, x4, and x5. So it will be 4 by 5 and then multiplied by 100. This will give you your percentile score for that person. So this is why you made few mistakes in the test, in the quiz, but hopefully you will not do the same mistake for your test. So this is what I just wanted to make sure that you know that what it is. Okay, let's go to today's lecture. This is discrete probability. Okay, so what today we are going to talk about the discrete probability, why it is important to study, because we make decisions in our practical life. We want to know that, for instance, what will be the forecasting for the weather, how likely that I am going to, let's say, have have some incident or have some accident if I go every morning, or if I travel every morning from home to this place. So how you find this kind of decisions in your practical life, how the insurance company make decisions, how come they are going to get the profit for their company. For instance, some people do gambling, how likely that they are going to win that game, or how likely they are going to lose those games. So it is very important for us to make decisions in our practical life. This is why we are going to study discrete probability. So it helps us to make decisions in our daily life. So this is why it is important for us to study. So in today's lecture, we will be basically doing some general calculations, which will be given in the form of tabular form, like tables will be given, charts will be given, and you need to figure it out what is the discrete probability and how likely you are going to make decisions on that. Another thing we will be discussing for insurance calculations, that how insurance company do get profit. Like for instance, in USA, it's very common to hear health insurance, and most of the health insurance are fake as far as I can see, because when it come, there is a time to pay for them, they don't pay you anything. They change their policies because it all depends on their profit, that how much profit they are going to get. I have to make the premium, pay the premium of $100 or $150 per month, and how likely that I am going to get a big accident and they have to cover all of the things to me back. So this is how they are going to get the profit. There we need the discrete probabilities. And the games of chance or casino games, how people do gambling and how likely they are going to win those games. This is what we will be discussing in today's lecture. So there will be a keywords, some definitions that you need to understand. Uh, what is random variable? Variable means that something that you could change. And random means by chance. Like, uh, I remember that I was talking about once random events, that each of the person has equal chance of being selected. So random is all about chance. So what does random variable means? That the outcome you get from your procedure, you do some experiment and you get some outcomes. So it is based on their chance. What is the chance that you are going to get certain outcomes from the procedure? So that is all based upon chance. So this is what random variable means, that and that the variable X will be a random variable if each of its outcome from the procedure is determined by its chance. For example, how many heads in a three flips of a coin? Like I flip a coin three times, how likely that I am going to get heads in that? So what is the chance in each procedure that I'm going to get heads in it? And similarly, if you roll a die, how likely that you are going to get 1, 2, 3, 4, 5, and 6. So it all depends upon chance that you are going to determine from the procedure. So this is called random variable. So what is probability distribution? So far we have discussed about frequency distributions. We are manipulating the same idea of frequency distribution over here that we will be using in the probability distribution. So what does probability distribution do? That it actually find the probabilities for each outcome of a random variable, and you write it down in a tabular form. So like the frequency, what we have done in the frequency distribution, you make a table and you make classes and you find the number of outcomes or number of people that occurred, the number of instances that occurred in each class. So that was frequency distribution. But here we are going to talk about the probability distribution. That means that what is the probability of each outcome you are going to get. Like in a roll of die, in this example, if you roll a die, how likely you are going to get X in how many outcomes we are having in rolling a die? We have six things, 1, 2, 3, 4, 5, and 6. So here we are using classical probability. So if you're using classical probability, you are writing all of these probabilities in a table form. So this is what probability distribution means. So there will be two types of random variables. One is discrete random variable and other will be continuous random variable. So this chapter is related to discrete probability. So throughout of this chapter, we will be discussing discrete random variables in it. So what does discrete means? Discrete means something that you can count, that is finite. For instance, how many number of students I have in this class. For instance, how many eggs I am having in a box, how many balls we are going to have in a play game. So these are all countable. But if something you are finding, let's say I'm finding the height of each person, then is it possible that I can find a person like 7 feet or 5 inches between, and 7 feet 5 inches and 7 feet 6 inches? Is it possible that we are going to get some person of the height 7 feet 5 inches and 7 feet 6 inches? 7 feet 5 inches and 7 feet 6 inches. So can we find a person in between these scales? So it is possible, because these are the intervals and there are many numbers in it. You might find 7.5000009, or you might find 7.51002. So there are many values, infinite number of values in between 7.5 and 7.6. So this is why it is continuous variable. But throughout of this chapter, in discrete probabilities, we will be discussing about only countable outcomes. Like for instance, rolling a die, how many are possible outcomes you can get? This is 6. So these are countable, discrete. So probability distribution, discrete probability distribution, we will be discussing the probabilities of each outcome that is countable. The X variable, convention is for the variable we use most of the time X. So probability distribution of X means that this will be countable The variable X will be countable, and you are going to find the probabilities for each of these items, for each of these values or outcomes. So just like frequency distribution, we are going to make the histogram for the probability distribution. So what frequency distribution does, that all the classes or all the labels, you make it on the x-axis, and the frequency you write on the y-axis. But in histogram for probability distribution, all the outcomes you will be writing down on your x-axis, and the probability for each outcome you are writing on your y-axis. For instance, we are going to take the weighted die. Weighted die means I talked about the craps, the game of craps, that if you get 7 and 11, then you can win the game. So what it does, it roll 2 dice. So we don't know that how many number of trials we are going to make in that. So how likely we don't know how many procedures we will be doing to win that game. Maybe a person is paying to play the game for 1 time and then 2 times or 10 times, we don't know. But the whatever number of times they are going to play that game, how likely that you are going to get 1, 2, 3, 4, 5, and 6. So let's say we don't know the number, but we are writing all of its probability from a given procedures that has done. Maybe it has done 50 times, and we are writing it down in a tabular form. So let's say this procedure has done 50 times. We don't know, but we are writing the probabilities of each outcome. You will not be asked to find the probabilities. It will be given to you in your question. But we don't know the number of trials, but from certain procedures, you have the table of this form. And here I ask you to make the histogram for this table. So what it does, the probability for 1 will be 0.001. So it means 5% chance that I am going to get 1 in that. So for 2.15, it means 15% chance, 35% chance that I am going to get 3, 30% chance that I am going to get 4, and 10% chance I am going to get 5, and 5% chance I am going to get 6. So you know that probability always exists in between 0 and 1, like certain or uncertain. If you remember that diagram that I made in slides, that 1 means for sure, certainly it will happen. 0 means it will not happen. But if something is in between, it's highly unlikely, in between 0 and 0.5, and 0.5 to 1, highly likely it can happen. So this is all tells you how many possibility that you are going to get this procedure. So if you count all the probabilities for a certain procedure, then it has to be equal to 1. Like for in this case, if you are going to take the sum of all of this probability distribution of each count of each variable, then this will be equal to 1. Like if you are going to add 0.05, 0.15, 0.35, 0.3, 0.10, and 0.5, so it will be equal to 1. So this has to be equal to 1. This means that your procedure, your experiment is correct, or this probability distribution is right. So one other thing is important to know, that probabilities cannot be negative. It cannot happen that some probability is minus 0.5. No, it cannot happen. So you might ask few questions about, or you might ask for this thing that, okay, tell me that this probability distribution is right or wrong. So if there is any negative probability, it means it is wrong. It cannot happen. If there is any probability that is going to, that is taking the value above 1, that is also not happen. That cannot happen. Or if any value that is less than 0, that can also not happen. So this is what it is all about. So let's see how we can make the histograms. So all the number of outcomes will be on your x will be on your x-axis, and p of x, the probability for each outcome, will be on your y-axis. So how many number of outcomes we are having? 1, 2, 3, 4. Let me see. 5 and 6. And the probabilities we are having, which is, let's see, I should make 0.05, 0.1, point, should make it smaller because I cannot cover it otherwise. So let's say 1, 2, and 3. 0.1, 0.2, and 0.3. And a little bit, this one is 0.4. So what is the probability of 1? It's 0.5. So it will be something like here. So 0.5 will be existing here. So this is for 1. So probability for 2 is 0.15. So it will be in between this number because 0.1 and 0.15 will be in between 0.1 and 0.2. So this will be the probability for 2. If you are taking the probability for 3, what is the probability of 3 in this given chart, which is 0.35. So 0.35 will be here. So this is the probability for 3. If you are finding the probability for 4, it will be 0.3. So this is for 3. 5.1. So this will be this one. And for 6, this is again 0.5. So here you are making the histograms for probability distribution. So this is also a touch graph and touch bars, I was going to call it, because histograms is a touch bar you are making. So this is how you will be making the histograms for the probability distribution. So in this procedure, you are from histograms, it is clear that most of the times we are going to get 3 and 4. But it's very highly unlikely that we are going to get 1 and 6 because the probability is very less from this procedure. So same lines, like frequency distributions, we also have to calculate the mean, standard deviation, and variance for the probability distribution. So how we are going to find the probability mean for the probability distribution? We know what does mean means. It's an average that you are collecting all the values, sum of all the values divided by total number of samples that you have been given. So in this case, we are going to write the formula for the mean of for frequency distribution like group data. This is the formula for that sum of all the values x times f. X was the midpoint. Do you remember? This is the midpoint for each class. And f divided by n, which is the total number of sample space, which is sum of f. So I'm rewriting this formula in another way. Can I write this thing as this one, like sum of x dot f divided by n? Because for instance, if I am having 35 by, let's say 10, can I write this thing like 5 by 10 plus 20 by 10 plus again 5 by 10 and plus 5 by 10? Can I write this thing? So if I can write this thing as this equation, I can split it into fractions. So same thing I have done here. So I'm rewriting this thing as sum of all the frequency distributions, like sum of x dot f divided by n. So I can also rewrite this as this thing, like x times, for instance, in this equation, I can take 5 out. Can I write this thing 1 by 10 plus 4 by 10 plus 1 by 10 plus 1 by 10? So this is the same thing, x dot f by n. So this is what I'm writing it here. And then what does it mean? F by n, what it is? F is the frequency, the number of outcomes, divided by n. N is the number of sample space, total number of sample space we are having. So what it is actually, F by n. F is your favorable outcomes and n is the total number of outcomes. So what it is, this is the definition we read, that you number of outcomes divided by number of favorable outcomes divided by total number of outcomes. What it is, this is the definition of classical probability. So this is our P of X. So I'm writing it down X times P of X. So it means if I have to calculate the mean for the probability distribution, then I am going to use this formula. Sum of all the values, which values that you are going to multiply each outcome with its probability, and then you sum all of these values, it will give you the mean. So this is what it is. For instance, in a weighted die, in a previous example, we were given all the probabilities for each outcome 1, 2, 3, 4, 5, and 6. So what it does, we are multiplying x times pf. So this is for 1 times 0.05, it is 0.05. 2 times 0.15 is giving you 0.30. So these are all the calculations. So, and 3 times 0.35 x dot px is giving you. You have to calculate each of these values. And how you can calculate the mean? That you have to sum all of these values x times px. Like you are adding 0.05 plus 0.30 plus 1.05 plus 1.2 plus zero point 0.5 plus zero point 0.3. So whatever the value it is giving you, that is your mean of the frequency distribution. Again, one thing you can analyze it here. Like for the frequency distribution, what we do, that for the like x times f of x divided by n, which is sum of f of x. But here, this sum of f of x, in um, in the place of f, we are having probability of x, because we are changing frequency with the probability distribution. So probably if you calculate all sum of p of x, if you will find sum of p of x, this is giving you 1, because sum of f is giving you n. But n is here equal to 1, because n is sum of p of x. In frequency distribution, n in a group data, we have sum of f, which is sum of all the frequency. But here we are going to take sum of all the probabilities for each outcome. So if you add all of these values, it has to be equal to 1. This is why n equals to 1. So this is another form. You can write it down. This is why we are going to get population mean is x times p of x. And throughout of this chapter, we are going to use the population mean and population standard deviation. The reason I will tell you in a minute why. So same like variance, we have to find it out. What was the variance for the frequency distribution? We had for the group data, variance was of the group data for frequency distribution was x minus mu square of it times f divided by n, because here I'm going to take population variance. Here is the answer. Divided by n. And if you are taking population mean, but n is sum of p of x, you are just going to replace f with p of x. So if you're going to replace f with p of x, so what it will give you? X minus mu square times p of x divided by sum of p of x, which is equal to 1. This is why we are going to get this formula, which is sum of x minus mu square times p of x. This is why the variance formula is this one. And what it tells you, what variance tells you, it takes the distance of each data value from the mean. So average distance of each data value from the mean. So we are going to do the same thing here. So this is the formula. But why we are not going to use the sample variance or sample standard deviation? The reason it is, if you find sample variance, so what was the formula for sample variance? Sample variance was x minus mu square times f divided by n minus 1. This was the formula for the variance for for sample variance for frequency distribution, group data. But if we are going to find the variance for the probability distribution, then n is sum of p of x. So we know sum of p of x, the sum of all the probabilities is giving you 1. So if this is equal to 1, then 1 minus 1 gives you 0. And something divided by 0 is infinity. So it is not giving you anything. It doesn't make sense, right? So this is why here we have to calculate mean variance and mean standard deviation and population mean, population variance, and population standard deviations we are going to use. This is the reason. So if you have to calculate the variance for the same example for the weighted die, so what you will have to do, you can use either of these formulas, like this one or this one. So this is just simple, the first one, because you just need to find square of f. So this is why I'm going to use here. So if you take x square, one formula for x, these two columns are given. The rest you have to find, because even for finding variance, you have to find the mean. So if you have to find the mean, then you have to take the product of each x with p of x, and you take the sum of x dot p of x, it will give you the mean, right? So this is why I have to find x dot px. So if you find sum of x times px, what is it is giving you? What was the value of x times px? 3.4. So what it means, 3.4, like average value is 3.4 for the weighted die. Can you think of it that what does it mean by 3.4? We are not going to get the outcome from the die 3.4. It has only 6 options, 1, 2, 3, 4, 5, and 6. It has not 3.4. So it means that on average, we are going to get 3 or 4 in the middle of it. Like for some experiments, for some trials, we are going to get 3. For some trials, we are going to get 4. Highly likely, because on average, we are going to take. So the same thing in histograms was given. Like if you see the histogram, that most of the values are in between 3 and 4. This is what it means, that on average we are going to get 3.4. Once you calculate x dot px, and once you find the mean, population mean, then you just skip it. You just make a line on it. The reason I'm asking you to make the line on it, because most of the students, what they do, that after finding x square, they multiply x square dot px with x times px. And I don't want you to do that mistake. So this is why, because this thing, the reason we are going to calculate x times px to find the mean. So once you find the mean, let's start calculating x square. So what is x square? Which is 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is giving you 25, and 6 square is giving you 36, right? So what is x square times px? Can you calculate for me? So x square times px, it means 0.05 divided by 4, because 1 by 4 times 0.05. So what it is giving you? Sorry, this is, no, I'm sorry. I was thinking this. This is 1 only. So 1 times, so this is 1 times 0.05. 1 times 0.05. This is giving you 0.5. 4 times 0.15. What is the value? 0.6. 9 times 0.35. 3.15. 16 times 0.3. 4.8. 25 times 0.1. Just to 2.5. And 36 times 0.05. 1.8. Right. So what is the formula for sample variance? This is x square times px. You are taking the sum of all of these values. Now you have to find sum of x square times px. So what is the value? You have to take the sum. 0.5, 0.5 plus 0.6 plus 3.15 plus 4.8, 0.5 plus 1.8. This is 13.35. So sample variance is sum of x square times p of x minus mu square, minus mu square. So this value is 13.35 minus 3.5 square. So what is the value? 1.79. So it means variance is 1.79. Once you find the variance, then standard deviation is just the square root of the value, this value. This is the radiant. And so radiant is basically the variance. And if you are taking the square root of it, this is giving you standard deviation. So if you are finding the square root of 1.79, what is it is giving you? 1.31. So this is standard deviation for the same example. This is how you will have to calculate. Now, the point is how you can find that in a given procedure, in a weighted die, which value is usual and which value is unusual. So you know what is unusual and usual values, that anything in between above 2 and minus 2. So what is above 2 and minus 2? Do you remember? That is z-score. So what does it mean? That 2 means that if something is the value that is 2 standard deviations away from the mean on the right and 2 standard deviations away from your from the mean on the left. So any value out of that is giving you unusual value. For instance, the normal distribution or the bell-shaped curve, what we done, like this is center is our mean. If you take 2 standard deviations away from the mean, so this covers this data values. So any value greater than mu plus 2 standard deviations, like more than 2 standard deviations, so in this region, this is unusual value, giving you unusual value. So any value in this section less than minus 2 z-score and greater than plus 2 z-score is giving you unusual value. So we know what does mu means. Mu means, second. What does mu means? Is the sample mean. This is sample mean. So in a previous example, like in a weighted die, what was the mean? 3.15? 3.4. Sorry, 3.4. Yeah, this 3.4. And standard deviation, what was the value of standard deviation? 1.31. So now you have to calculate mu plus 2 standard deviation, which is 3.4 plus 2 times 1.31, and find the value mu minus 2 standard deviation, which is 3.4 minus 2 times 1.3 value. So what are these values? 6.0? 0.8? 2. Okay. And this one? 0.78. Okay, so okay, I think we have done some mistake in the variance or something. But anyways, If we see, let's suppose we have these values for mu plus two, like two standard deviation and less than two standard deviation on the left and two standard deviation on the right. So any value above this will be the unusual value. But for the weighted die, how many possible outcomes we are having? 1, 2, 3, 4, 5, and 6. So does this cover any value more than 6.02 and any value less than 0.78 will be the unusual value. But 1 till 6, 1, 2, 3, 4, 5, 6, all of these values cover in these two intervals. So no value is unusual. Are you getting my point? Like, because the possible outcomes, how many outcomes we are having for X? 1, 2, 3, 4, 5, and 6. So the interval you find for the two standard deviation, which is 0.78 and 6.02. This is the interval you find for mu minus two standard deviation and mu plus two standard deviation. So away from the mean, two standard deviations away from the mean, you find the interval, what it is giving you. This is the interval for 0.78 to 6.02. But all of these values, all of these outcomes are existing in between this interval. So it means no value is unusual. All values are usual. But let's suppose if I had, if I was finding after my calculation something like interval, sorry, here interval, let's say I'm finding 1.5 to, let's say 5.04. So then do we have any value which is unusual in this interval? I'm just fictionally, I'm supposing the interval that, let's suppose we are having this interval. Then 1 is not covered in this interval because 1.5 is further right. 1 is not covered in the, 1 is on the left of this interval. And 6 is also on the right of this interval. So it does not cover these values. So in that case, 1 and 6 will be the unusual values, and 2, 3, 4, 5 values are usual values. This is what it means, right? So this is how you have to calculate the usual and unusual values. So one other thing, if probability of any event is less than equal to 0.05, so that will be considered unusual. This is why I was wondering, because probability of 1 in this example is 0.05. So it has to be unusual. There is something that we did some mistake finding some calculations, maybe in variance or standard deviation. This is why I was thinking this, it has to be unusual. Because the reason it is unusual, probability of any event which is less than or equal to 0.05, it will always be unusual because we know that in normal distribution, what it does, that how many data values it covered, if it is two standard deviations away from the mean. If your z-score is -2 and z is +2, this is the mean. How much data will be covered in this portion? Like one standard deviation, do you remember? 68% of data will be covered if it is one standard deviation away from the mean. Two standard deviation away from the mean, then it will cover 90, 95%, I guess it was. Yes, it was 95%. But if it covers three standard deviations away from the mean, then it is covering 99.7%. Yeah, 99.7%. So if, and we know any value that is out of this interval, out of two standard deviations away from the mean, like if any value is above two standard deviation away from the mean on the right, or any value below two standard deviation away from the mean on your left, then that values will be considered unusual. So how many data will be covered on the rest of the part? This section will cover how much data? Because 95% data covered in two standard deviations. So how much data left we have? Which is 100 minus 95%, it is giving you 5%. So 5% data is covered in this, in these two sections, the left part. So this is why, so these are unusual values. This is why if your probability of any event is less than or equal to 0.05, that means 5% of probability is giving you, or less than that, so then it will be considered unusual values or unusual event it will be considered. This is why I was saying that 1 and 6 has to be 1 and 6 has to be unusual data values, outcomes, because their probability is 0.05 for both of these. So let's suppose we are flipping the coin 1000 times. So what is the probability that we are going to get exactly 501 times head in that? So for instance, if I am going to flip the coin 100 times and I want to get exactly 60 times head, is it possible? Yeah, it is possible, but it is highly unlikely that you are going to get the exactly outcome that you are going to get. It is possible, but the chances are very less. It could be a little bit around or more than that or less than that, but you cannot find exactly that, but it can happen. This is why their chance is very less. This is why their probability is equal to 0.0252, which is less than equal to 0.05. This is the unusual event. And if you are going to find the probability for from 1000 time of flipping the coins, you are doing the procedure that you are flipping the coin 1000 times and you want to get 501 or more head, then their chances are highly likely that it can happen. So this is why the probability is 0.487, like 48% chance at around 50% you can get. Do you know the large number of values, law of large numbers? I told you, because if you do like 1000 times, you do some experiment. So it's highly likely that your the classical probability, empirical probability will be approaching to the classical probability. This is why it can happen that 50 times you are going to get the head or 50 times you are going to get the tail. So it might be around, but not exact, but highly likely that when you do the experiment many times, then the probability will be the same for both of these events. Same thing is here. So we know that 60% in this example, we know that 60% of the people are side sleepers. Choose 5 people and X is the number who sleep on their side. So it is not going to tell you that how many group of people we are having in it. And we are going to make the groups of 5 people and we are serving for each of the 5 people and check that how many people are side sleepers in that. So here we are taking 5 people and we count that 60% people are side sleepers in that. So for instance, you are taking 5 people, it might happen no one is sleeping on their side. So it is probability is 0.0102, which means that 1% people are sitting on their side. And 1% you find that 0.0768, like 7%, around 7% chance that 1% is going to sleep on their side. 23.04% that 2 people are sleeping on their side. 34.56 percentage that 3 persons are going to sleep on their side. So these are all the probabilities for this that they found. So what you have to do, you have to calculate the mean and standard deviation. It means on average, if you are going to do this procedure many times, I don't know how many times, maybe 50 times, maybe you go outside and you survey 5 people and then you find that how many people from these 5 people are side sleepers. Same thing that I am going to go out and I am going to survey for the 5 people and I am checking that how many people are on sleep on their side. So this is why we don't know that how many times this procedure has done, but no matter what the number of times this procedure has done, we found that 60% people are sleeping on their sides. So this is the data we are having. So if I have to find the mean and standard deviation for this probability distribution, so it means on average, how many people are sleeping on their sides. And same the standard deviation you have to calculate. So for the mean, what you will do, you will find x times px. You have to make the column and find it for each of the values. The first one will be 0 because 0 times whatever the value is giving you 0. For second, this is 0.0768 because 1 times 0.0768. So the rest of the values you will count by yourself. So what you will have to do in the end, you have to take sum of all of these values, which will be giving you the mean of this probability distribution. For standard deviation, what we have to do, I told you, once you find x times px and once you find um, the mean, then you just skip this column, write the column for x square times px, and then you take the sum, and then you find sum of x square times px, and you will subtract it from mu square, which is mean, the square of the mean. So this is what you will have to do, and you will take its square root. This is giving you the standard deviation. So what is expected value? Yes. So another form of, because now we are going to do practical examples, we are going to calculate the insurance company, how they are going to get profit, or how likely that if we do gambling, how likely that we are going to win the game or make some money, how likely it can happen. So average means is, it is also called the expected value. Average mean is the average. So theoretically, we say average as the expected value. Like probably we are like, for instance, in a weighted die, you find the mean that was 3.4. It means, what does it mean? The mean is 3.4. It means probably you are going to get in between 3 and 4. So that means expectedly we are going to get 3 or 4. So when we do practical examples, real world problems, there we are going to call it expected value, not the mean. But the meaning is same. But theoretically, when you write, you will call it expected value. Like if I want you to find what is the expected value of winning this game, what is the expected value of my profit if I win this game, so that is the same thing is calling the mean, that you are finding the mean of from some probability distribution. You need to make the, first of all, the chart probability distribution that we are going to see that how to make that. So theoretically, we are going to call it expected value. Here is an example one. So we are going to find out how insurance company works. So in this example, it states that an insurance company insures farm ground for $300 per acre if the ground is destroyed and the crop does not come in. The probability that the farm ground is destroyed is 1 out of 120. Like in 120 farms, you might have one farm will be destroyed from 120 farm grounds. The company charges $8 per acre to insure crops. So it means a farmer has to pay the premium $8 per acre. Find the expected payout for the insurance company and the expected profit for that company. So you have to calculate it. Did you get my point? So let's see it in a graphical way. Let's say he is a farmer and here is our insurance company, right? So in order to insure his farm ground, he has to pay the premium of $8. So what are the options that insurance company is going to pay back to those farmers? In this case, we have two cases. One, if the farm get destroyed. If farm get destroyed, then insurance company is going to pay back $300. And another possibility is the farm is not getting destroyed. It's completely fine. So if nothing happened, they are paying $0, right? So this is what is going to happen in the insurance company. So we have to find that what is the profit, how much profit the company is going to have, and how much payout they are going to have, how much they are paying for the people. They are not getting insured one person. They have many people, many customers that are going to get their insurance. So what are the two possibilities? So we are going to find what we have to find expected value, and expected value for anything symbolically we will write it E of whatever you have to find. So we have to find expected value of payout and expected value of profit that the company is having. This is what we have to calculate. So it means we have to make the probability distribution for the payout, like how many outcomes we are having, total possible outcomes we are having for the payout if it is destroyed. And the second option is that the farm is not being destroyed or nothing happened. So one choice we are having destroyed, and another choice is nothing happened. So what will be the outcomes? What is the payout that the company is going to pay to the farmers? If it is destroyed, that the company is paying $300 if it is destroyed. Second is nothing happened, then they are not paying anything, zero. What are these probabilities for both of these payouts? If the farm is destroyed, land is destroyed, then they are paying $300. But what is the possibility? What is the probability that the farm will be destroyed? It is given in the statement, isn't it? That the probability that the farm ground is destroyed is 1 out of 20. 1 out of 120. So what is the probability if nothing is going to happen? As we have only two possible outcomes, one is happening and one is nothing is going to happen. So it means if nothing is going to happen, everything is fine. So this probability is actually the complement of probability of being destroyed. So this means 1 minus 1 by 120. Do you remember the complement events? Like P of A bar, do you remember? So probability of event plus probability of complement of that event equals to 1. So it means you are taking the complement, nothing is going to happen. So 1 minus 1 by 120. This is why we have to write it like this. So what it is, with this is 119 by 120. So now we have the values. I am just keeping it little bit clean so that it will be easy for me to do the calculations. 119 out of 120, right? So now we have to find what? We have to find that what is the expected payout for the company. So expected payout, like on average, the company is paying what? What is the expected payout? Expected means I told you that this is theoretical meaning of average. So on average, company is paying what to the farmers? So it means expected payout is, you have the outcomes, the payout they are going to pay 300. This is actually X, or this is probability of X. So you are multiplying 300 times the probability of farm is destroyed, plus the other option is nothing happens, so they pay $0 times the probability of nothing happen is 119 by 120. So now you have to calculate these values. What is the payout? Can you calculate for me? Which is what? Yeah, it is 2.5. So this is 2.5. So this is actually, it means expected payout in dollars, $2.05 they have to pay out for the farmers. What does it mean? So it does not mean that $2.5 company is going to pay each of the farmer. It does not mean this. It means that if we have lot of people who are buying this insurance and they are going to pay the premium of $8, let's say we have 500 customers and 500 customers pay them $8, each of the customers. So on average, there are chances that something is going to, something will be wrong. It can happen or something will not be wrong, but the probability of something is going to get wrong is very less, which is 1 by 120. So if anything goes wrong, so they have to pay $300, right? So if something happen or something does not happen and you take the average of all these payouts, then on average they have to pay $2.5 on each of the customers or the farmers. So this is what it means. So so on average, the company is paying $2.50 for on every farmer. So if you have to find the profit, that how much profit they are going to get, so you can also make the probability distribution the table, but we know the profit, we know uh, how many how much money or how much premium they are going to pay. So each person is going to pay $8, and on $8 on average they are going to pay how much? 2.5, which is $2.50. So if you subtract it, so what will be the profit? $5.50. So this is the profit for each company. So it means if customers, all the customers, like 500 customers buy the insurance, then on average, on each $8, they are going to get the profit of $5.50, even if something is going to get wrong. So this is how insurance company works. Any questions so far? Everything is good? Maggie and Tia? Let me know if you have any questions. Okay. The next example is on the similar lines. I want you to think on it for, I'm giving you 2 minutes and thinking on it that how you can do it. So pause this at this stage and think on it that how will it work. So what it says, an insurance company, this is also insurance company profit. We are going to count that how much expected payout. The insurance company insures a person for $1.5 million if that person is abducted by aliens. To get this insurance, the person has to pay the premium of $150. So if the chance of the person getting abducted is 1 in a million, so what is the insurance company's expected payout and what is the insurance company's expected profit? This is the same thing, but you have to think on. So 1.5 million um, is the is the payout that they are going to pay for a person if the person being abducted, or for to get this insurance a person has to pay $150, like each of the customer is paying $150 to get this insurance, or if something get wrong or being the person is abducted by aliens, then they are the company is paying them 1.5 millions. So 1.5 million means you are not going to write it $1.5. This is in millions. So if it is millions, so that means you are writing it this way. What will be the probability distribution here? What kind of probability distribution you are going to make for? What is required? You are required company's expected payout. So it means you have to, on the similar lines that you have done for the farmers insurance company, So here we are going to do the same thing. So what two incidents are going to happen? Something is going to wrong. That is that if a person is being abducted or is getting abducted by the aliens, and something, if he is not getting abducted by some, nothing is wrong, then what is happening? They are not going to pay anything. So, and what is the probability? Probability, is there anything anywhere given in the probability in this statement? Chance. Chance means probability. If the chance of the person getting abducted is 1 in a million, so it means 1 out of 1 million. This is how you will write. So this is a probability of 1 in million. So let's make it. Two incidents we can have. One is abducted, a person get abducted by the aliens. This is a silly thing. It cannot happen, but in case it is happening, but it happens. This is why I'm giving you the site that you can search it for. And one other incident is nothing going to happen. So which is nothing happen. So what will be by? If a person get abducted, then the company is paying 1.5 million. So if 1.5 million, we will write it. We are not writing it down $1.5. It is 1.5 million. So this is how you are going to write it down. And if nothing happens, then the company is not paying anything. What is the probability of each of these incidents? If someone get abducted, is there any chance? Yes, it is, because it's given. If the chance that the person getting abducted is 1 in a million, so it means 1 out of million people. So nothing is happening. How you can find the probability? Because we have only two incidents happened and nothing is going to happen. So this is the complement of happening. So which is 1 minus 1 by million. It means this is 999,999 divided by 100,000. So this is how you will write it down. Make sure you are not doing any mistake. These are 7 digits. If you are taking one less, don't write 7 times 9. It is 6 times 9. Most of students do this type of mistake. So these are 7 digits. On above, it has to be one number less. So which is 6 digits. So 999 and 999. You have to write down. So this is the probability if nothing is going to happen. So how you have to find the expected payout for the company? Expected way of the payout for the company, you are going to get the outcome. What is the outcome? One is they are paying 1.5 million. Probability for this thing is happening is 1 out of in a million, plus nothing is going to happen times the probability 999,999 divided by 1 in a million, which is this way you are going to write. So if you simplify it, what will it be? These are 5 zeros and these are 5 zeros. So it's 15 by 10, which is 1.5, right? So it means they are going to pay $1.5. So $1.05. It's not million anymore, because you have divided the millions, lots of zeros with the lots of zeros of the million. So this is expected payout for the company. So what will be the profit? The profit is, so it means they are paying on average. It's not like that every customer or every person is going to get $1.5. It means because they have a lot of customers And even if something get wrong and nothing get wrong, on average, they are going to pay on each person is $1.05. So it means the profit will be the expected profit for the company, how many money they are going to get from each customer, which is how much they are going to get? 150 from each customers. So, and how much they have to pay out, you are subtracting that money. So that is the profit, which is 1.5. So 148.5. See how much money they are making on each customer? A lot. It's a millennial. So this is why I don't trust on insurance companies, because they just make money. When you need it, they don't pay anything. So yeah.
If you get abducted by aliens, where are you going to be to collect the money?
And these are silly reasons, silly things, and it doesn't happen, but still it happens. Do some people buy these things? And sometimes I do get surprised. People have a lot of money to waste on. So this is how the profit. Okay. So what is the next example? Okay, so this is a little bit different. Let's see. Expected value for what? It is fine. You have to find. Assume you work at an insurance company. On average, an average 22-year-old man walks in and wants to get life insurance this year. This year, it means for a single year, he is going to get the life insurance. And how old is he? 22-year-old man. So they he wants to get the life insurance for three lakh dollars. So $300,000 he wants to get. It means that if he die, then his family is going to get $300,000 if he buy this insurance. Based on the Social Security's actuarial life table, how much would the expected payout be? Because now, what is the probability that the person will die? And what is the probability that the person will live? We don't know these things. So if we don't know, we have to figure it out, that how we can find it out. If this is the case, then how much they are the expected payout for the company, and how much would you charge the person if the markup is 10%? So how it means, if he is going to get this insurance, that a person has to pay 10% on the expected payout. Like, you have to calculate the expected payout. So it means a company is paying on average the amount they are going to pay. Then on that amount, the 10% amount he has to pay for buying this insurance. But we don't know the probability that the person is going to die or live, because we don't know the insurance company data, that because they have sometimes lot of data to figure it out, that how likely this person is going to die. Like I was talking about, that how likely I am going to have an accident when I go out of the home. So it cannot happen every day or every time. Likely it happen, but very rare. So you have to figure it out, what is the probability. So you have to check from the actuarial life table. How I can find out? Let me go on this thing. So actuarial social security, actuarial life, what was the name? Life table. Okay, this is. So this is the data we are having for 2016. You can also figure it out for different years, 2021 as well, but here it is not. So let's see 2016, what is the probability we are having? So in this table, we have male and female, and these are all their ages on their left. 0, 1, 2, 3. These are all the ages. So on the right side, death probability is how much? Like if an infant is like baby born, how much likely if a male, if a boy born baby, like 0, this is why it is written. So the probability of his death is 0.006304. It means very uncertain that he is going to get die. Uh, so like 0.6% that the infant is going to have death. And if it is 1 year, so this is 0.000426. These are the second column. Can you see it? Death probability. And can you see the death probability for the females in the right column? They have two columns, male and female. In the very, on the very left section, the age is written. But in this question, we are going to figure out for the 22-year-old man. So here it is at the bottom line, 22 years. And next to it is the probability of his death, which is 0.001407 for the male. He is a male. So if he is a male, so I have to write it down somewhere because I need it. Let me see. Point probability for death of 22-year-old man, which is 0.001407. So now I am going to use it. Let's see, where is it? Okay. So the probability for 22-year-old men die is 0.001407. And it's written male, male is going to walk in and he wants to get the insurance. So here are two possibilities. One is die and one is he live. Two scenarios we are having. So the expected, the payout, how the company is paying back to the customers. If he die, then they have to pay 1.5 million, which is 150,000. And if they live, or if he live, then they are not going to pay anything, $0 they are going to pay. What is the probability that a person is going to die and they have to pay the amount of $150, which is, we found from the actuarial table, which is 0.001407. And what is the probability that a person is going to live? This is actually the complement of die. So if the person is dying, which is 1 minus 0.001407, what is the value? 0.998593. This is the probability. So now the expected payout for the company, let's figure it out, which is a person die, then they are paying how much amount? 1.5 million times the probability a person is dying, which is 0.001407. And then if they plus, if he lives, then they are not paying anything, 0 times 0.998593. So it means, so this right side will be 0 because of 0. So what will be the value of 1500000 times 0.00147? This is 2000.5. So it means expected payout will be this one. So $2,110.05 they are going to pay on average to the customer who are buying this insurance. And you have to figure it out that how much a person is going to pay. The person is going to pay if the markup is 10% on the payout. So the 10, it means 10% of this amount he has to pay. So if you have to find the 10%. So what in English way, you have to write 10% of 2110.5. So what I do, I manipulate off with times. 10% means 10 by 100, and I write the value 2110.5. So think anything 10% of this value, that means you just have to multiply divided by 100. So now you have to calculate the value. So this is 2, which is, of course, because just one decimal place, 211.05. So the a person has to pay. So this was in the question, how much he would be charged. So a person will be charged for this money. So a person is being charged 10% on this way. So charge is 10% of $210.05. So charge will be $211 or 5 cents he has to pay for buying this insurance. This is what it is. So next one is lottery. Okay, this is another one. How many examples? I think it's 3 more. Okay. So this is another example for the lottery. You know that when we go to the Walmart, we have some lotteries are there that have on each, you have to pay $1, some are on $2, some are $10. So they have price on it. So now we will see that how it works and how likely you are going to win the lottery. So a lottery is held, 10,000 tickets are sold at $1 each. So it means, let's say in Walmart, they had 10,000 tickets and they all were sold at the amount of $1 for each. There are 5 prizes each for $1,000 worth. So it means from 10,000, 5 tickets had worth the price for $1,000. 30 tickets had worth $100 price on it. 50 tickets had $10 price on that. And the remaining tickets has nothing on it. So you are just wasting money of $1. I do not want to pay even $1 for these tickets. So find the expected payout if the person buys a ticket. So what is the payout for the lottery or the states who make their these lotteries? How much they have to, on average, they have to pay out for these lotteries to a customer if they buy these tickets. So this is what we have to check here. So now we have, it's not like the previous example. Now we have more than one incidents, 2 incidents. So the incident is they are selling the lotteries, and how many total number of lotteries we have? N is 10,000 lotteries we have, right? So if we have N, it is easy for us to find the probabilities, right? So N is 10,000 lotteries. So it's just like the insurance, do you remember the company? And a farmer was going to pay to the corporate, but instead of insurance company, we have lottery here. For the lottery, a person pay $1 on each ticket, and how much lottery people have to pay to the customer. So we have here 4 options to pay back to the customers. One is they are paying $1,000 on 5 tickets. Another is they are paying $300 on 30 tickets and $10 on 50 tickets, and the rest they have nothing. So it means, so the rest we have, they are paying nothing on it. So this is how they are paying back to the people. So now we have to check that what is the expected payout for the lottery people. So how many incidents we are having? Chance is that 5 tickets. Let me remove this so that I have more space to write down. So there are 5 tickets have price, and how much price is on 30 tickets has some price, 50 tickets has some price. So it means 5 plus 30 plus 50, how much it is? 85. So 85 tickets has some price. The rest of the tickets, how much will it be? 10,000 minus 85. How much will it be? 9,915, on which they are paying nothing. They don't have any price on that. So it means lottery is paying 5 tickets, they are paying $1,000. 30 tickets, they pay $100 price on it. 50 tickets, they have $10 price on it, and the rest they have nothing. Now, how you have to find the probabilities for each of these outcomes? These are the tickets. These are also N1, N2, N3, and N4. So probability is 5 is from those 10,000 tickets. So probability 5 tickets from 10,000 have worth $1,000. So $100 they are paying if on $30 tickets out of 10,000. $10 price on 50 tickets out of 10,000, and the rest they have nothing. So how much? The rest is 9,915 lotteries out of 10,000 have nothing on that. So now you have to calculate the expected payout for the lottery. How you are going to check? Again, you have the all the payouts, which is in the form of prizes, and their probabilities you are going to have. But what you have to do, you have to just multiply all of these prizes with their probabilities. So 100,000 times 5 out of 10,000 plus 100 times 30 out of 10,000 plus 10 times 50 out of 10,000 and plus 0 times whatever the value, it will be 0 because of 0, 10,000. Now you have to calculate. So these three will go with this. These three will go with this. These 30 will go with this. So 5 out of 10 plus 3 plus 5. So this is, how come? I made some mistake. Oh, 10,000 is not 1,000. So divided by 1,000, 10,000. So these three gone, 10,000. So these two zeros gone, and this will be 0. So this will be 3 by 10 plus 5 by 100. So what it will be, when you calculate it, your value will be 0.85. So it means 85 cents they are going to pay on average to each person who buy these lotteries. These are the payouts. So it means, so you should play this game or not. Now you have to decide. I think you should not. Why? Because over the time when you continuously playing this game over and over and over, then on each $1 you will lose 15 cents. So this is not a good deal. You are losing the money more than getting it. But they are going to get the profit. The lottery people, they are going to get the profit of 15 cents on each ticket people are going to buy. So it means if they bought 10,000 tickets, then on 10,000, if they are going to get the profit of 15 cents on each, so it will be around $1,500. They are going to get the profit on it. So this is not the good deal, but they are going to get the profit because taking out money will be 1,500. They are going to get the 1,500 over spending, which is how much their payout is. This is you include it. So how much will it be? The payout will be like on 0.85 times, you multiply it with 10,000, so that will be 800 something you have. But the profit they are going to get, which is in $1,500. So it is not the good deal for us to play this game because on each dollar you are losing 15 cents on it. This is why this is not the good deal. Anyways, okay, I am going to tell this another example. The last example, I'm leaving it on you. So why I made this table, uh, what was the craps game? So in craps game, what do you do? That you roll two die. If you're going to get 11 or 7, then the chances that you are going to win the game. But if you are rolling two die at once, that how many possible number of outcomes you can have. The one die has 6 outcomes, another die has 6 outcomes. So the total number of outcomes um, will be 36, right? And here you have the probability you have to find that if X is the sum of the numbers on the two dice, let's say one die has 1 on it, another die has 3 on it. So the sum is giving you 4. So in this type of, these are the probability distribution. How you calculate these probabilities, you can easily calculate with these table. You can also make it on Excel. The rule is addition because we are adding all of these outcomes. So how many outcomes we have on one die? 1, 2, 3, 4, 5, 6. Another die outcome, which is 1, 2, 3, 4, 5, and 6. If you add 1 and 1, so what will be the value, which is 2? If you add 1 and 2, what will be the value? 3. 1 and 3, it is giving you 4. 1 plus 4 is giving you 5. 1 plus 5 is giving you 6. 1 plus 6 is giving you 7, right? Second row, this is 2. Again, you are multiplying 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. You are adding and then you are writing in that row. So this is what I'm doing. 2 plus 1 is 3. 2 plus 2 is 4. There is a reason I'm making this table. For this question, you don't need to make it because you just need to find mean and standard deviation. I'm writing this table because I need it for my next question. So this is why I'm writing it down to show it that how you find all these values. So 2 plus 3 is 5, 2 plus 4 is 6, 2 plus 5 is 7, 2 plus 6 is 8, 3 plus 1 is 4, 3 plus 2 is 5, 3 plus 3 is 6, 7, 8, and 9, 4, 5, 6, 7, 8, 9, and then 8. Sorry, 10. This is 10. And then 6, 7, 8, 9, 10. 5 plus 6 is 11. And then this is 7, 8, 9, 10, 11, and this is 12. Can you see one thing that diagonally it is same, diagonally it is same, diagonally it is same, right? So it means what is the probability that when you add two die and add the two numbers of die outcome, which is 1 and 1, and you are getting 2, how many outcome we are having, favorable outcome we are having to get 2, which is 1 only in this table. So how many total numbers we are having, which is 36. So 1 out of 36, this is the classical probability. I'm writing it down. The number of outcomes, favorable outcomes, divided by total number of sample space. So how many times we have the sum of two die, which is giving you 3, which is this row. So 2 times it is happening in this table. So which is 2 out of 36. This is why we are writing these probabilities this way. If 4, how many possibility that when you sum the numbers on the 2 die and you are getting 4 in that, which is 3. So this is by 3 by 36. 5 is occurring 4 by 36. So the number of times 5 is occurring, the sum of values, which is 4 times. This is why the probability is 4 by 36, and so on and so on and so on. So we are going to use it here. In this example, we have a dice. In this game, we have a dice, and the player has uh, two, the players roll 2 dice on this. So if the dice sum to 2 or 12, then the player wins $6. It means if the dice sum 2 die, they are rolled at once. And if their sum is 2 or 12, then the player is going to win $16. If a person rolls a 7, then the player is going to win $2. For playing this game, a person has to pay $1 to play each time this game. So what is the expected profit of the game, and should you play this game? So this is gambling. They, for each rolling a die, they are paying $1. So for instance, if the roll is, so what is happening? The experiment is rolling a die, and the outcome is the sum of the values you are getting. So if you roll 2, or I should write it down. If you roll 2 or 12, then you are going to get how much they are going to get? $6. So it means the customer will get, so the profit will be $5 because $1 he paid to play, and from six, if he is getting $6, so the $5 he is going to get by paying $1 each time. So if he roll 7, then he is going to get the amount of $2. So player wins $2. It means $1 he is getting the profit because $1 is he played for, and $1 on top of it. And he is not getting anything for the rest of the outcomes. Anything for the rest of outcomes. So it means 0. This is our Y. So the payout probability. This probability, this is why I made that table, so that you can figure it out. What is the probability of getting the roll of 2 or 12? So getting the roll of 2 or 12, which is for getting a roll of 2, which is 1 by 36. And for getting a roll of 12 is 1 by 36. So if you are adding them together, do you remember probability of event A or B, that is additional probability. So this, we are going to get the probability of first incident plus the probability of second incident. Same thing we are doing here. So 1 by 36 plus 1 by 36 is giving you 2 by 36. This is the probability for rolling a die of 2 or 12. If he is rolling a die of 7, like sum 7, then what will be the probability? For sum 7, the probability is 6 by 36. So here we are writing it down, 6 by 36. So what will be the rest? We know that sum of all the probabilities equals to 1. So it means if you add them together, these two probabilities, it will be 8 by 36. So 1 minus 8 by 36, how much will it be giving you? 28 by 36. Are you getting it? That how did I get this? Which is 1 minus 8 by 36. And this 8 is 2 by 36 plus 6 by 36. This is how I find the probability. Now we have to calculate the expected payout for uh, the gambling, right? For what? For this game, what is the expected profit we have to figure out? Sorry, not payout. Payout we know. The profit we have to find. So profit we will find once we know the payout, then we can figure it out, the profit. So expected payout will be $6 they are paying on rolling die 2 or 12, which is the probability is 2 by 36. $2 they are paying for rolling 7. That probability of getting 7 is 6 by 36, plus nothing is going to, they are going to pay for the rest of the outcomes, which is the rest of the outcome is 28 by 36. So now you have to calculate. So if you calculate it, I have the answer, which is 0.67, I think I have. So this is the expected payout on average for the players, the gamblers, the gambling team is going to pay. But what will be the profit for you? The profit for you, the for you, you are paying how much? $1. So the if you subtract the payout, it is giving you your profit 0.33. It means 33 cents is your profit. But if you are losing this money, then 60 on each dollar you are losing 67 cents. So this is not the good deal to play this game again. So on similar lines, you have to do this example, right? So think on it, that how you have to do it, and I'm leaving it here. If there is any problem, you can discuss it later. So far, you have any questions? Okay. See you in the next class.